The ultimate method for hand mixing.
Hi, I'm Wayne Caddy at Sourdough Slingers. In today's lesson we're going to cover hand mixing and two of my favourite techniques, autolyse and stretch and fold. I'm combining those two together. Also in this lesson we're going to discuss water and final dough temperature. At the end of this lesson I'm going to talk about final dough temperature and the best way of achieving this with a simple calculation.
Any leavened dough is going to be temperature sensitive. That's because yeast acts differently to different temperatures, so a warmer dough compared to a colder dough will ferment quicker. So if we can control the final dough temperature, the FDT, we're in charge of fermentation and essentially how the dough acts. Also, there's another consideration that a lot of people don't realise, and that's that gluten is also temperature sensitive. So a warm dough will mix quicker and a colder dough will take longer to mix. And that's because the gluten is a little bit like a bed spring, if you like, and the warmer it is, it opens up as a coil. The colder it is, it shrinks back and coils up tighter. For my recipe I'm using 40 degrees water. I've worked this out so that when I mix my dough, my final dough temperature is going to be 24 degrees C. I'll give you this calculation at the end. Most baking problems are related to temperature issues. I like to use a rectangular tub to mix in. You can use a round bowl, that's absolutely fine. I find it so much easier to mix in and it's really easy to keep clean. It's also a great space saver, really easy to store. I'm making a large batch of dough here. If you're making a smaller batch, why not use a lunchbox? Autolyse is a technique of just combining flour and water together, and sometimes a pre-ferment, but generally flour and water is good enough. And this promotes extensibility. That's why we're not adding salt or yeast. Salt has an astringent effect on the gluten. Don't spread or open your fingers whilst mixing, as this will lead to more dough sticking to your fingers. And the yeast activity, which produces carbon dioxide, also tightens the gluten. Remember, autolyse is all about relaxing the gluten and hydrating the starches. Enzymes also begin to break down the starches into sugars, which act as a yeast food. You can also scrunch the dough. After mixing, clean down with a dough scraper. I'm using a metal dough scraper. A plastic scraper will work absolutely fine. When mixed, there should be no visible flour remaining. After mixing the autolyse ingredients, it's going to be extremely craggy and undermixed, but don't worry, that is absolutely normal. Allow to rest for the minimum time of 30 minutes or the maximum time of 24 hours. The longer we autolyse, the less mixing. After just 1 hour rest period, our autolyse has really changed the dough. Can you see it's a lot more extensible, soft and silky. You can see this in the window test. Now we move on to dough mixing. Here I'm showing you a couple of options on pre-ferments, a dark rye levain and a wheat levain. Using pre-ferments is up to you, it's totally optional. You may also use commercially yeasted pre-ferments such as Polish, Bega or Sponge. I'm using a liquid levain in this recipe. Use the stretch and fold technique to mix through the liquid levain. I always add my liquid levain or any pre-fermenting first. It helps with the extensibility, so it makes it easier to stretch and fold. If you are adding yeast into your dough, this is the time to do it. If you're making sourdough, obviously we don't need to add any yeast in. The scrunch method incorporates ingredients through the dough quickly. Then continue to stretch and fold. The amount of folds that you put into your dough will vary. Firmer doughs, like the one I'm mixing today, at around about 60% water, won't take as many folds as a higher level hydration does, say around 70% upwards. They will require more stretch and folds at the mixing stage and also the bulk fermentation stages. See how the dough becomes tighter after each stretch and fold. It's good to scrape down after each stretch and fold. The salt is always the last core ingredient to go in, as this tightens up the dough and it makes it really difficult to stretch and fold. I'm adding the salt gradually, and that's because we don't want to shock the dough. Press down to key in the salt. I'm using my fingertips to press into the dough. This is called docking. For me, it's a real effective way of putting the salt into the dough. Then stretch and fold. Salt makes the gluten stronger. It also controls the rate of fermentation. Repeat this process until all of the salt is mixed through the dough. Some breads require other ingredients, so after our core ingredients of flour, water, salt and yeast, other ingredients can go in. Unless they are part of the liquid or hydration, for example, eggs or milk. Continue to stretch and fold. The dough is becoming stronger and stronger, and that's through the folds, but also the addition of salt. I fully mixed my dough, and now I'm checking the final dough temperature, which is 24 degrees Celsius. That looks nice and healthy. After the mixing process, we begin bulk fermentation and stretch and fold. During the bulk fermentation process, the yeast produces lots of carbon dioxide and ethyl alcohol. The gluten also becomes extensible and relaxes. During the bulk fermentation, we also add more stretch and folds. The stretch and fold adds strength, degas the carbon dioxide to make it smooth, and also even out the final dough temperature. It's also really important to realise that folds happen during the bulk fermentation time period. So for example, my dough has a 4-hour bulk fermentation and I'm going to put 2 folds in at 1-hour intervals. Let's say my dough was mixed and started bulk fermenting at 12 p.m. My first fold would be at 1 p.m, second fold at 2 p.m, and then for the remaining 2 hours, the dough would bulk ferment until 4 p.m. After the full bulk fermentation time, my dough is a lot gassier and softer and extensible, but it has good strength. Now, your dough is good to shape, prove and bake.
Hi guys, thanks for watching. Final dough temperature is important to attain consistent baking results. As we discussed earlier, yeast and gluten are sensitive to temperature. Water temperature is key to achieving final dough temperature. The ideal final dough temperature for a yeasted dough is 24 degrees Celsius, and for a wild yeasted dough it's around about 26 degrees Celsius. Here's how you calculate the final dough temperature.
Here's a simple final dough temperature calculation for hand mixing. You'll need a digital thermometer. Follow this simple formula. Flour temperature plus room temperature and the total. Then we have a magic number. So the magic number to make this formula work for a yeasted dough where we're adding baker's yeast, whether it's fresh or instant dried yeast, is 80 to 85 degrees C. For a sourdough, it's a different number and it's 85 to 90. Okay, so they make the formula work. Don't worry how we got there, it's a little bit like Pythagoras. So for example, in the recipe I used in this class, I used a water temperature of 40 degrees Celsius. How did I get there? I'm going to take you through this step by step now. So my flour temperature was 20 degrees C. My room temperature was also 20 degrees C. So my final total was 40. Because I used a yeasted dough, I used my magic number of 80 and then I took it away from the 40. So therefore that gives me a water temperature of 40 degrees C, so that when I hand mix my dough, I will achieve a final dough temperature of 24 degrees C. So if we have another example of a yeasted dough, same dough but a different day, and it's a colder day, and our flour temperature, let's say, is 10 degrees C. Our room temperature, let's say, is 16. That gives us a total of 26. So we're still working on a yeasted dough, so the magic number is 80. Okay, so what that allows us to do is pull down this number here, the total number. So 80 less than 26, and our water temperature is 54 degrees C, which will still achieve a final dough temperature of 24. In this example, we're going to use a sourdough, so the magic number actually is 85. And remember, the range is 85 to 90. You can move up or down on this scale. Let's say the flour temperature is 20. And let's say that the room temperature is also 20, which gives us a total of 40. If we bring in our magic number of 85, we bring down the total of 40, which gives us our final water temperature of 45. And that will achieve a final dough temperature of 26, because we're looking for a final dough temperature of sourdough of 26 degrees C. Sourdough tends to move and ferment slower than commercially added yeast. That's why we're going for a warmer final dough temperature.
Don't forget to hit like and subscribe.